Hello, I'm Chris Hornstein. I'm going to be going through how to use the testdriven.net application. Um, the first thing that you want to do is download testdriven.net from that very website and install it, and then open up Visual Studio. And assuming you already have a project, you can just skip this step and go straight to your project, but I'm going to create just a quick example, and I'll just call it a console application. And the first thing that you want to do is add a new project to your existing solution called, the name of your project plus tests or something like that, and make it a class library. So I'm just going to say example tests, create that. And then you need a reference to InUnit. When you install testdriven.net, it installs just a few different versions of InUnit, so you can navigate to that, which is usually just in your C drive. In the testdriven.net folder in program files, and then there will be an InUnit folder. You can select a version, and you should probably just use the latest unless you have a specific reason not to. The next thing you want to do is add a reference to your test class saying using InUnit.framework. This just includes some of the standard functions that InUnit offers for testing. And then the next thing you want to do is create a test class. So I'm just going to rename the existing class. We'll call it example tests. And then you want to label that class a test fixture. And then you want to create a function for testing. And let's just take a moment to write like an example function that will give you kind of something to work with. So the idea behind test-driven development is that you stub your code and write tests against that code before you even start coding in the first place. So I'm just going to create just an outline of a class, and we'll call it number functions, and we'll make it public, and we will say let's just define a simple example function that adds two numbers, and it takes two ints and then returns them added together. So what we want to do is we just want to stub this function. We don't want to actually implement it yet because we're going to write tests to help us with the development. So then we'll go back to our test fixture and we'll add a new function. So I want to write a test function that basically tests out the functionality of the add numbers function that we're working on. So first I need to add a reference to that project, and now that I've got that, I can go ahead, pull it in, and then I want to create a test, and it's going to be the add numbers test, and I highly recommend using some sort of naming convention for these. And then there's a bunch of assert statements that the InUnit framework offers. So I can say assert r equal, and what I want to do is, let's say I want to get 10 out of the add numbers function. So I will say number functions add numbers, and I want to put in say 4 and 6, and that should give me 10. Okay, so at this point, if you've installed testdriven.net in Visual Studio, I can just right click and say run tests, and it's going to tell me if this passed or failed. And here is the output. You can see expected 10 but was 0 at add numbers test. So the add numbers test failed. So what we want to do is now develop with these tests in hand that ideally define the correct output for a bunch of different values, so we have solid testing for our functions. So we'll go ahead, go back to the number functions class, and I will implement this function now. Okay, now that I've done that, I should be able to run the tests again and see 1 passed, 0 failed, 0 skipped. So this is kind of the crux of test-driven development. This obviously is, you want to have your tests be a lot more robust, but the concept is that you stub out your functions, write tests against them, and then you can see if they passed or failed. It gives you a couple of advantages. You can go back to your code now and see if you want to refactor. Once you're done refactoring, these tests better still pass, or you've got either a problem with your tests, or hopefully it's identified a problem with your code instead of the tests, because you want your tests to be really robust. So in addition to just the R equal, there's a lot of different assertion functions you can use, um, like is empty, is false, is instance of. There's just plenty of options for you to use, and you want to just make sure that the tests cover all of the use cases that you want your functions to be covering. So once you do that and write these tests, you've got a solid testing framework that you should be keeping probably just in your source control repository with the actual project. And this provides both usefulness during development and after development when people come back to the project, because these tests are really hopefully defining how your project works. And it helps you not only to test your project, but understand how it should be working. Because if you can't write these test cases, then you probably shouldn't be writing the program if you don't know what your function should be doing. So it's really handy, and it's pretty easy to use with the help of testdriven.net. I highly recommend it.